Randy Richard in the shop, and we're continuing with the Hemingway kit's spherical turning tool. So a little catch up to where we're at. So we've got the slide, part way done and fitted here. Just came out. They came out really nice. Very, very pleased with how this all came out. The head is pinned to the shaft. The body. The only thing I have to do to the body is still drill the oil hole on the side. We have these bronze thrust washers came with the kit, so I just threw them in, and we have the boss and the washer made. We still have holes to drill in this for positioning the handle and locking it to the shaft. Now, I showed in the previous episode, I turned this to about 850. Well, I forgot to put in the thrust washers for spacing, so I threw those in there, remeasured, and so 3/4 as per the drawing is okay. It's just a tiny bit longer than the shaft, so that's good. And so I turned this down to 3/4. So this is where we're at. Everything operates and is very smooth, and we have the where is it? And we have the lock, what they call the lock nut, partially made here to fit in this hole right there. And we still have to put a hole. Now they say to thread it at 1/4 40. So that's going to be a little bit of a challenge. I do not have a tap that will go 1/4 40, that's for sure. So a small hole, internal thread on the lathe. What a challenge. Anyway, this is where we're at. So here's the detail drawing. Here's the thread detail. 1/4 40 through hole. Well, one thing we're going to do is we're going to have this set up here like that. We're going to drill a hole splitting the difference between the slide and the head, and it's about 1/2 inch. I believe it's 1/2 inch hole, because we're going to have an adjusting screw here. Show you the here we go. You can see there's an adjusting screw that will have graduations on it that pass through the lock nut. This hole needs to line up with your thread hole, so positioning of that is going to be kind of critical. Now it has a stem that goes in, and I think I could probably put that hole in it, getting a rough estimate where it goes, because the height would adjust within the bore, the other part, the base of the unit. So you could, put the hole, within a few thousandths of this here, and this will slide in, and then you could Loctite it in position. It doesn't have to necessarily be seated in anything for exact positioning. I can figure out that at the last little minute here after we get the hole for the graduated adjustment dial and put in. You can see here's the adjustment dial right here, how it's split between the two. So I'm up to this point here where it says assemble the slide into the head with the one end overhanging, and we'll away from the nut. So here's the brass lock nut, goes in that hole. We'll flush it on this end, and it'll be sticking above 1/8 of an inch. Then it says to fit the handle and the boss and washer. That is the only mention in the drawings about the handle, boss, and washer, about making them. So I stopped and I went and made them. I just kind of read ahead. Okay, well, I'll get those made. Those are 2 simple parts, and you saw that in the previous part. Now I need to. Then they talk about locking the slide in place through this M5 hole you put in the side with the knurled M5 knurled screw. Well, this is the only mention about the M5 knurled brass screw that needs to be made. The details are right here. So we're going to go get that one made Right now, this is a big deal setup for me wise on the lathe, to do this on the lathe. I have to put in, only my big lathe can do metric threads. This is a small part, so I'm going to set up the 5C collet attachment in the lathe, take the chuck off and all that, and get the gears set up so I can do M5 by 0.8 pitch metric thread, and we'll get this made. I decided to show you real quick about my collet attachment. I've already slipped it in the back and attached it to the spindle. A slight ordeal in itself. This is the spindle nose cover piece. This is the part that goes in the spindle to actually fit the collet. This is a Morse taper number 5 internal here, so this is an adapter to fit the 5C collet. On the end of the shaft, you have to put this nut so that you can spin the male thread on the end, and you have to spin the collet end to thread on, so it's kind of a coupling. Basically it's a coupling nut. This has a snap ring down about halfway through here, so you can only thread it in so far there and thread the collet in on this end. Now I made a wrench that I could reach in and engage the dogs to put this on. It makes it a little bit easier, because you can't have the nut on when you slip the collet attachment through the spindle. So you just thread it on. It doesn't have to be very tight, really. You might have to actually adjust it per different collets if they're not quite the same. This goes on here. This is not just a protector. I'll show you. It's also the removal tool for the adapter. So after you put that on, you put the adapter in. When you loosen the nut, it will pop the adapter out for you. Now in a previous video I showed fixing this. Somebody had worked on this in the past and they had braze it, brass brazed it, whether they may have cracked it or I don't know what, because I couldn't find a crack in it or anything, and so but it wasn't concentric, and the collet, it was horrible. So I machined off all the brass they had back here and cleaned it all up. And then I reground it. And now it works extremely well. So I have a witness mark right here and on the face that's the position I ground it in. So this always goes on the same way. And that way I always put this in, because this is keyed on there. And then I just tap that in a little bit, and then we can put the collet in. And I turn the collet closer to thread it in the back. So we're sitting getting some snow today. About 4 inches out there right now. There we go. You can see the little bit of movement. This is actually a very nice collet closer. Let me get my stock. Yeah, there's a brass stock, 1/2 inch, goes right in. And then you adjust it. See, that's not very tight yet, right? And keep adjusting a little bit till it cinches down good and cams over on the closer. There, that's solid as can be. I haven't used the closer in actually a little bit. Now that I have that 6-jaw, boy, that makes it really nice. Here, we'll put a dial on it and see how it is. Bump on the. Now it's just raw stock, so it's not even been turned. and it's less, right about a thousandth, I should say, not less than a thousandth of an inch. This is a half thousandth indicator. No, this is a 1,000th indicator. I'm sorry. No, it's 1,000th out, which is not horrible at all. Being rough stock. If it was a machined piece, yeah, it's 1,000. Being a machined piece, it would be slipped in there. It'd be better. Yeah, it's still 1,000th. It's actually kind of funky. It's a surface. It just kind of has a bump in it. That's really less than that. Anyway, that'll work really good for what we need to do, because I can't hold stock this small in my big chuck, in my 6-jaw chuck. All right, we'll just face this end off, and well, we could do it this end too. We'll just use this end. Let's get it rolling. Stock in there. I got a piece of high-speed tool steel bit in there. I faced it off. Now I moved it down 15-30 seconds is the dimension for the threaded portion. So I'm just going to put a little mark. We'll turn it down to 5 millimeters. Put a little bigger nose radius on the tool, get it cut a little better. We'll take a 50,000th cut here. Yeah, just take a little bit off now. We're looking for 197. It should be right there. We like that. What I'm gonna do, I think I'll skim cut this outer, just to make it so it's all smooth. We're going to knurl the outside of it. We're going to knurl that outside part. Alright, I got the gears changed on my lathe to hopefully do a 0.8 millimeter pitch thread. All set to metric, my levers and such. I'm ready to do a scratch pass. I have a 60-degree tool set in there. And we're just going to do just barely not even a half an inch worth of thread. We're only going to go up to that shiny line. Now I'm going to leave this engaged. The half nut, we're going to bring it back, and I will not be disengaging the half nut. I'm going to do a test. How fast can I stop it? Oh, it's pretty fast, so. And then I'll back it out, reverse the lathe. Go back far enough that I'll get rid of the backlash. So I get rid of my backlash when I come in. I come back far enough. Okay, so get it checked here. Got the magnifiers on, and it's right on the money. Hey, how about that? What a deal! Now I have my compound set at 90 degrees, so it's parallel with the axis of the lathe, and I'll be just using my crossfeed dial for depth of thread. Alright, I've calculated that the depth of thread for a 0.8 pitch is somewhere between 21 and 23, minimum maximum 21 and 23 thousandths. Since my dials on my lathe are in thousandths, that's why I've corrected it to that. So we'll just make some cuts. I made a small test piece here. So I'm at 20 thousandths, and it's actually not too bad. It's a very good fit. I should say there's no play in that, but it does screw on. Actually, it screws on good. I think we'll just leave it right there. So I went to 20 thousandths, and I calculated between 21 and 23 according to metric thread calculations. So that's sweet. That worked out well. Now we'll just knurl this on the end. I've got the Canadian knurling tool on there, and I've given it a little tension and lined it up with the center line, and we're gonna just give her a rotation here. Take a look at it. Not too bad. A little more tension. Couple more turns. I think we're going to call that good. So that doesn't look too bad. We'll do a little chamfer on each edge and part it off. I forgot to turn the camera on parting it off, but I cut a groove with the parting tool, hit the file on that edge, and then parted it off. I still have the nub to remove. Came out pretty good though. So for this part, whoa, okay. They have an elaborate explanation of how to mount the whole thing on your tool post, put a faceplate on your lathe, and actually square the end with your lathe and drill this hole. The hole is split between the slide and the head here. I decided to do this in the mill. I think it's a lot easier. So I just centered up on my shaft. I touched off each side, found the center of the shaft, and moved over. And then I put the wiggler in and aligned it on the split seam of the slide and the head here. You can see that. So I think we're good enough there. Now I'm just use the spotting drill and we'll start our drilling process. I have a 1/4 inch drill in here. They want me to drill a 1/4 inch drill, 1.25 inches deep. Boy, that's a That drill's got some run out. Change to a different drill. Now a 5/16 drill to 1 1/4 inch. Now I'm supposed to put in a 1/2 inch slot drill. I don't know what a slot drill is. I need John Mills here to interpret the instructions for me. Anyway, I have a 1/2 inch end mill, and we're going to go 5/16 deep. Then we're going to take it out, flip it over, center up again on it, and do some drilling from the other side. Since I use the shaft as my center this way, if I don't move the table on my y-axis, I should be still centered over the joint. So what I did is I put a stop on, a 1 inch gauge block in against the shaft. So now when I flip it over, I'll just be on the other side of the shaft, and we should be centered right back up where we are. We're using the back of this as a reference against the jaw. Same plane, same shaft, just the other side. We need to probably push that down though, huh? That looks a little better. I flushed it up and then put it back in. So now we're good. We should be. Oh, exactly on the money. Perfect. Perfect this way in the Y, and perfect in the X because of the centering on the shaft. So I don't have to move anything. Center drill. Now I'm using a 3/8 spotting drill. We're going to go back in with a 1/4 inch drill. And we're only going to drill until we hit where the counter bore is for the nut. Now we're going to go back in with a 1/2 inch end mill until we enter that counter bore. I can see the counter bore down there, so I got into it. Down into the counter bore. Go a little deeper. We're going to drill it. Now we're going to put a 1/2 inch drill in and drill it deeper anyway. Well, we got our little lock nut done, or locking screw, nut part number 9. A lot of work for me to do that. Having changed the gears on my lathe, making a smaller thread cutting tool and such. But you know, it came out good. I'm pretty happy with it. And what I did here, since I did not thread this up to the shoulder, I counterbored that a tiny bit with a 204 drill. So this now screws in all the way very nicely and will interfere with the slide. Slip that in and locks it in place solid. So that came out really good. Really happy with that. We'll get the next parts done.